Hello friends, welcome back to our YouTube channel VLSI4freshers. In this video, we will discuss about static timing analysis interview question STA interview question which is asked in the interviews or STA profile or physical design related profile. In this video, we will discuss some basic questions related to STA. This is the first part of our STA question series. So please go through this whole video. You will get the best idea about a STA question. So what do you mean by STA? What is STA? So it is a method of checking the timing performance of design in the worst condition. It means it's checking the timing, not checking the functionality. It will only the timing analysis. STA checks the timing only, not the logical functionality. It will check. STA performs a check on different timing constraints. What are all the timing constraints we will discuss next in the video. And this timing analysis is carried out independent of input. And it does not need require any independent of input to carry out the timing analysis. So these are the basic definition of STA. STA means static timing analysis. There is a word static in this, which means it is independent of the input. There is other timing analysis also, that is DTA, dynamic timing analysis. So what is the actually difference between the STA and DTA? Let's see. As compared to DTA, STA is very fast, much slower compared to the STA, DTA. DTA is slower and STA is very fast as compared to DTA. Functionality of design are not checked. In STA, we not check the functionality of the design. That working of the design is working fine or not. It will only do the timing analysis of that design. In DTA, all the functionality of design and timing requirement can be verified. In DTA, we do the functionality of the design also. But in DTA, we need a separate verification team to write the test bench or test vector to perform all that DTA tasks. But in STA, no separate verification team needed because it is independent of the input vector. STA analyze all paths and user need to enter whether to ignore or consider the critical path in the design. It means if you want to ignore or consider some path, you have to tell the tool that is in the constraint file. In DTA is the best way to analyze the asynchronous and multiple clock domain. DTA is best way to analyze the asynchronous and multi-clock domain. And STA analyze all the paths. If you want to ignore any path, suppose any exception like false path, then you have to tell the truth, this start point and end point is my false path, please ignore. In STA we do this thing. So this is the basic difference between STA and DT. That's why we use STA in industry. Now next question, what are the input required for STA? So basic input required files is a netlist file, library, constraint file, parasitic information. In get list, you all the connectivity, logical connectivity of your design. Libraries is like .lib file in we have the timing information of macros and standard cells. Content we have the all the timing related constraints, false path, multi-cycle cycle path, clock definition, input output delay, maximum input maximum minimum delay. All those are in the constraint. Parasitic information with RC value in the spec file. Resistance and capacitance value in the parasitic file it is present. Now next question is what are the timing paths? How many timing paths are present in the timing in STA? One is data path, clock getting path, asynchronous path. How many type of data path is present? Input to res to res to output, or input to output directly. This is the input to output direct. Data is going directly from input to output. This is direct input to output path. So these are all the data related path. Input to res to res to output. Clock getting path is now next is clock path. Clock path is this two path. Capture clock path in which this is the capture flip flop. This is the launch flip flop. This is the launch clock path, and this is the capture clock path. Now the asynchronous path. Asynchronous path which is going through the signal in the preset or clear. This is the asynchronous path. So these are the basic paths which present in the STA. The next question is what are the different major steps for performing STA? How will tool this? How will tool calculate the delay, or how will tool decide? How will tool performing the STA? Tool break down all the design into sets of timing path. What timing path? The timing path which is covered above. Then calculate the delay along each path. Then tool calculate the delay along each path. And then check for timing violation inside the design. Based on the delay calculation, we get the values of timing violation inside the design. We will discuss later what type of timing violation. Now next question is, what do you mean by clock gating path? How do you define a clock gating path? If there is any gated element within the clock path to control the behavior of as per the input of gated element, that type path is called clock gating path. Like this. This is the clock. This is the gated element, and this is going to the flow. So this is the clock gating path. On what is critical path? The path which creates the longest delay is called path. The path which creates longest delay is the critical path. Sometimes no sensitive path is also called as critical path. So this is the basic definition of critical path. What is false path? It is a path that cannot propagate a signal. Means it cannot propagate any signal through that path. In the design, there are several paths which are logically incorrect paths. So these paths are false paths from analysis point of view. In this, there is 2 mux. Input 1 is going to the output 1. This is the false path. Next question is, what are the different checks STA will perform? What kind of check we perform during STA? Setup and hold check we check. clock gating check, recovery and removal check, latch-up and time borrow concept, vertical path and false path, minimum pulse width. So these are the basic checks that we perform while during performing the STA. This kind of question, which is asked in the synopsis interview question for the STA profile. What kind of checks you perform in STA? This you have to answer. What do you mean by a hold time of a flip-flop? Hold time is the amount of time that a signal should be stable after the clock so that the data are reliably sampled. It is the minimum time of required data should be stable after the clock so that data can be reliably transferred to sampled. What are the various ways of timing optimization in chess tool? Logic optimization. If possible, please reduce the number of logic between the flip-flop to speed of the design. If possible, reduce the number of logic between the flip-flop between the speed of the design. It means if there is two flip-flop, how many logic level present in between the design? If there are 20 number of gates or 20 number of combinational cells, so then you have to decrease the sum number of logic cells between to speed up the design. In VLSI company we term use LOL, logic level. There is some, depending on the project, we get the guideline what should be the logic level between two flop. So logic optimization option, if possible, please reduce the number of logic between the flip-flop to speed up the design. Next is optimize the drive strength of the cell. You can change the drive strength of the cell to optimize the timing. Use LVT, SVT cell. These are the faster, but these are the very leaky cell. Power will increase. So you have to choose very carefully by using the SVT or LVT cell during the timing fixes. What do you mean by timing model? In a design, once a block has met its timing constraint at gate level, the detailed internal timing of block is not needed for chip level analysis. For that, we can write a timing model for that block. It means if you have a design and timing constraint is met at the gate level, so the detailed internal timing of the block is noted for the chip level timing analysis or full chip level timing analysis. For that, you can write the timing model for that block only. These are some basic timing models. ETM, extractive timing models, QTM, quick timing models, INM, interface logic model. So ETM, ETM, and ILM. These are the timing models. So this timing model we will discuss in detail in later video. What do you mean by input delay? Input delay is a constraint that represents the arrival time at the input part of design with respect to the launch clock. It is the delay that represents the arrival time at the input port with respect to the launch clock. Next question is, what is source clock latency? Delay from the clock source to the clock definition pin in the design. That means clock generated here and the delay from the clock source to the clock definition is the clock source latency. Clock network latency is the delay from the clock definition to the flip-flop of the point. This is the clock latency. Clock network latency. So these are two type of latency: clock source latency, which is from source to definition. Then otherwise is clock network latency. It is from clock definition to the flip point clock pin. Total clock latency is source latency plus network latency is the total clock network latency. So these are the basic clock source and clock network delay latency question. How many types of clock are in there? Three types: synchronous clock, asynchronous clock, exclusive clock. These are the three basic type clock: synchronous, asynchronous, exclusive. What do you mean by clock uncertainty? It is the time difference between the arrival of clock signal at register pin in one domain or between the domain. It is the timing difference between the arrival of the clock signal at register pin in one clock domain or between the domain. What is clock is? It is the difference in the arrival between two sequentially adjacent registers. Clock skew, it is the difference in the arrival time between two sequentially adjacent registers. It means how much time is the difference between between two flip-flop. The time is clock reaching. The time is called clock skew. Clock skew is of two type: positive clock skew, negative clock skew. When the launching flip-flop receives the same clock age earlier than the capturing flip-flop, it is called the positive skew. And when the capturing flip-flop receives the same clock age earlier than launching flip-flop, it is called negative clock skew. Here it is the launch clock to the capture. Here it is capture, here it is launch. In positive skew, launch coming early, then capture age is coming. This is positive skew. In this, capture clock is coming early, then the launch clock. It is the negative skew. So this is the basic definition of positive and negative clock skew. You can explain into the interviewer with the diagram. He will get the better idea. Now next question is, what is global skew and local skew? Local skew. When we calculate the arrival time with difference of clock signal between related clock, it is local skew. When we calculate the arrival time difference of clock signal between non-related flip-flop, it is called the global skew. If we calculate the timing difference, arrival timing difference of clock signal between related flops, it is local skew. And if it is non-related flip-flop, it is called the global skew. Next question is difference between the pre-CTS or post-CTS in design. It means pre-clock tree synthesis, post-clock tree synthesis. Pre-CTS clock are ideal. Post-CTS, we have the clock tree building, clocks are propagated. Second, clock uncertainty during pre-CTS is clock skew plus clock jitter plus margin. But during the post-CTS, we clock jitter only margin. Clock skew gone because we have the real clock value. Real clocks are propagated. Next question is, what is cell delay and net delay. Cell delay, timing delay between an input pin and an output pin of the cell. Cell delay information is contained in the Liberty file, .lib file. And net delay, it is the interconnected delay, the RC delay between the driver pin and the load pin. Net delay is equal to the RC delay of the wire. It's based on the R resistance and capacitance value of the net. This is the net delay. And cell delay is the timing delay between an input pin and an output pin of a cell. And it is present in the .lib file. RC value present in the STA file, that parasitic extraction. So these are the cell delay and the net delay. Next question is, what is CRPR? CRP. What is CRP? Clock recovery and pessimism. When the launching and capturing clock share a common path, the path common, minimum delay and the maximum delay will add a additional position measure both setup and hold analysis. CRPR can be used to remove this pessimism. So when the launching and the capturing clock share the common path, the path common path minimum delay and the maximum delay, we will add additional pessimism to both setup and hold analysis. And CRPR can be used to remove this pessimism. CRP is equals to latest arrival timing to common point minus earliest arrival timing to common point. While launching and capturing clock share common path. That path is, this is the launch clock path, this is the capture clock path. But the path, it is called the common path. It is coming in the launch clock path also, and this is coming in the capture clock path also. So this is the common point. The path common, min delay and max delay, we will add the additional pessimism to both setup and hold analysis. CRPR can be used to remove this pessimism. Latest arrival to common path minus earliest arrival time to common path. Tool automatically remove the pessimism as per its algorithm, then check the violation. Now, if the number of violations is decreased, then final number of violations are considered as real violations, because remaining violations are practically possible violations. Next question is, what SDC file contains? The object design constraint. It will contain timing constraint, clock period, the needed clock definition, input output delays, maximum min delay, timing disable timing timing exception like false path, multi-cycle path, half cycle path, false path. FCP is false path. SCP is half cycle path. MCP multi-cycle path. These are the timing exceptions which we have to give in the constraint file. Next question is how to calculate the setup and hold select. So this is the launch flow. This is the capture flow. This is the input D, output Q, combination logic D, Q, clock, launch, capture. So arrival time is clock delay of flip-flop 1. This is clock to Q. This is maximum plus combinational delay. This is we calculate the arrival time. Now the required time, clock period plus clock delay of flip-flop clock 2 minus setup time. Now setup select equal to required time minus arrival time. This is how we calculate the setup select. Similarly for the hold, arrival time equals to clock delay of flip-flop minimum, clock to clock delay flip-flop 1 minimum plus combinational delay minimum. Required time is equals to clock period plus clock delay of flip-flop plus hold time. Clock period is equals to 0 because hold is analyzed at the same edge. So clock period is 0. So hold select is equals to arrival time minus required time. This is how we calculate the hold select. And setup select is required time minus arrival time. These are the basic equations to calculate the setup and hold select. Next question is what is metastability? In a flip-flop, if a setup and hold violation, timing violation take place, it results in an unpredictable state known as metastable state. So in a flip-flop, if you have a setup and hold timing violation, what will occur? The result will come, unpredictable state will occur, which is known as the metastable state. In metastable state, the circuit is unable to settle to either logic 0 or logic 1 within time period. This will further fail the system functionality. So in metastable state, the circuit will not unable to settle either 0 or 1, and this will cause the further fail to the system functionality. It happens due to the toggling of the flip-flop during the clock transition. So you have to fix the timing violation. Metastability, circuit unable to settle at either 0 or 1, and it will occur due to the because we have the setup and timing violation. It results in an unpredictable state known as metastable state. It happens due to the toggling of flip-flop during the clock transition. Next question is what is OC? On-chip variation. All devices along a chip should run at a specific speed and interconnect should either at worst case or best case corner. All the devices along a chip should run at a specific speed and interconnect should be either at worst case or a best case corner. But due to some variation at fabrication level, the speed is not uniform throughout the chip because of the OCV, on-chip variation. The on-chip variations are variation in the IR drop variation, variation in threshold voltage, variation in channel length and weight transfer width, variation in temperature, variation in interconnect. So these are the some basic OCV which is happened due to the fabrication level. So we did all these OCVs wall chip variation, we have to take care it in the STA. So these are the some basic question which asked in the STA interview or PD interview. In next part, we will discuss more question in STA domain. Some numerical also we will see in the next part. How to calculate the setup and hold select. Till then, please go through this video. If you have any doubt, please comment. Thanks for watching. Please subscribe back to our channel. Like, share and subscribe for more updates. Thanks for watching.